welcome to both of you. Thank you so much for joining us here on Retconning Weekly. So, David, I want to actually start with you because you were pretty into a language called Elm. Adam, have you ever heard of Elm? Not the mail.
I think we actually talked about it on the show at some point.
We talked about Elm here.
Yeah, I think so.
Okay.
And I wasn't
Elm,
even
the
here.
language.
Speak of the deep cuts. Yeah, no, I think so.
Elm, not the mail reader.
No, not the mailer.
Okay. Because I always think of the mail reader that had a 2 gigabyte limit that forced me to go to Mutt when my mail box got larger than 2 gigabytes. Got that 31st bit. But Elm. So Dave, you were super in Elm, and you've got a great story about something you had developed for Elm, based on a new feature of the language. Yeah, and can you describe that a little bit? Because it
was just a talk that I had signed up to give at OSCON, the O'Reilly conference, open source conference, which I'm not sure if they do anymore, but in 2016, and it was about this feature of the language. So Elm there's kind of a debate about whether the fact that there hasn't been a commit in 2 years means it's dead or not. But it's a functional language for writing web UIs, basically. So you would think of your UI as a pure function of the state of the program, and it had this neat feature called signals, which was a kind of a stream of data, a value that would change over time. So like the mouse position would be a signal where it has a value at any given one time, but you can also accumulate over a series of values, and you would treat it like you would accumulate over a list of things, with a fold. So it was this very elegant functional programming abstraction applied to UI, and it was, I think, very appealing to people who were into functional programming. And so I wrote this whole talk just kind of explaining it, and it was a neat little intro to functional programming, framed around this feature. And then the talk was going to be mid-May, and then May 10th there was a blog post called a farewell to functional reactive programming, where they were getting rid of signals from the language. So that was really exciting. I had to rewrite my talk in a week. Mostly I just kind of crammed it into the middle 30 minutes and gave 5 minutes at the beginning and end about how they were removing this, but it's still kind of like that. Hasn't changed that much. It's more they're getting rid of the name, and had to kind of explain it. But I learned that if you're going to give a talk on something, you better watch the mailing list for that thing.
This is so ridiculous at so many different levels. And first of all, how often? I mean, I feel like languages are generally, for a good reason, like careful about ripping out abstraction. Like when you introduce abstraction, like people are going to build software on it, and they may even write talks around the software they built on it. And you can't really be casual about ripping that out. But they're like, no, it's dead. Farewell to the thing you're about to give a talk on. How old was it? Couldn't have been that old when you gave it.
It was a couple of years old, probably, but it started out as like a kind of a research project, I think, by the creator Evan Splitsky, and I just posted the talk and the post announcing removing the feature in the chat. Yeah, I mean, it was still evolving a lot at that time. This was early. This was not the time we are now. This was 2016. Things were a little bit more fluid in web world, where TypeScript hadn't really become dominant. So I think the value proposition of these non-JS compiled to JS languages was stronger than it is now, where you have to have a really strong value proposition in order to justify deviating from the thing that's now the mainstream choice, which is TypeScript, and is really good.
The days of CoffeeScript and many other interesting things.
Yeah, I think even by 2016, CoffeeScript was already kind of on the way out, and it was like, okay, there's TypeScript, Flow, Elm. We're still compiling to JavaScript, but we're not doing this weird pseudo Ruby thing.
Is Stephen O'Grady paying either of you a bounty to mention CoffeeScript here? Out of curiosity, I mean, it would be. Because I was a CoffeeScript malcontent, because I think unlike Elm, I think Elm is really interesting because and TypeScript is terrific. I mean, I think TypeScript, actually, I think TypeScript is it is almost more important than JavaScript in terms of like TypeScript. Am I understating the importance of TypeScript? It feels like TypeScript is a very important development. Am I understating that?
Yeah, I don't know how it. I mean, I think if you look at the language rankings on GitHub and stuff, you'll see it's quite high. I'm not sure if it's quite reaching JavaScript yet, but it's a very significant amount of new web app development definitely is TypeScript rather than JavaScript.
It definitely bridges an important gap because it's like we had a lot of compiled to JavaScript languages in many different ways. So, things like Elm that were grouped more to frameworks. You had things like PureScript, which were more functional, but definitely harder to sort of get started with. You had things that were much looser, like CoffeeScript. And then, you just had straight JavaScript compilation of like, here, let me take E to 5 to 6, then became Babel to, make this like language translation as the language was evolving, so heavily from the sort of ES5 to whatever the new generation was. So the language was really evolving. The type world was kind of slow, but when TypeScript came together, it was a really interesting alternative to a lot of these things. And then you also had Flow from Facebook, which they just never really got their... they never put as much effort into it because Facebook Meta has always been, very internally like, this is for us and you can use it, but it's our toy and we'll sort of do what we want with it. So,
yeah, and at this point, they basically said as much that, development is going to be internally focused on Facebook's needs, and they're not really doing open source stuff with it anymore.
With Flow. Yeah, I'd forgotten about Flow, actually.
For a while, looked like it could go either way. Between TypeScript and Flow.
In terms of Flow or TypeScript.
Yeah.
Yep.
Yeah, what's funny is that Adam, Dave, and I were in Aarhus with Lars Bach when Microsoft was announcing TypeScript in 2012.
Oh, really?
Yeah,
cool.
And there was a really interesting, and so Lars Bach did the V8 VM at Google, and so Dave and I were presenting all the work that we had done to Lars and Casper Lund and kind of all the debugging work. And the Microsoft guy, Steve Luco, was also coming over there to have like a closed door session with that we were kind of like literally a fly on the wall for. Like they kind of didn't ask us to leave and we didn't volunteer to leave. So we're just going to stick around and watch it. And they were just going at it. They were like two cats in a bag. Because it's kind of like like neither wanted to cede anything to the other. It's like Lars like, why would you do any of this? I'm like, I know why you do any of this. Like, this seems extraordinarily valuable. So it was super interesting and a very, very important development because it brought Justin, as you were saying, like, I don't think CoffeeScript, it's amazing. It's like CoffeeScript is actually like looser than JavaScript. Like, how do you do that? But I think that TypeScript was really bringing something very important, which is a lot of rigor and type safety. And types are nice, actually.
Yeah. In particular to folks, with a certain collection of values, building a certain type of software. Like, I think there are lots of folks for whom TypeScript might be overly constraining, like the people who choose untyped languages for the rest of the world. But, certainly, like, if you believe in types and think that types are good on the server, like you might think that they're pretty useful on the client as well.
Well, you got to keep in mind too that like in the early 2000s, JavaScript was a very different language than it was today. It's like really in the 2010s especially when Rails was really at its meteoric rise, people were using a lot of Ruby and are like, okay, this makes sense. I can write some really terse syntax and do a lot of stuff and throw a lot of code out in the world. And CoffeeScript really hit that era when JavaScript was like getting out of this very painful stage where it was kind of an awkward, incomplete language. And they're like, okay, we can kind of see it's starting to move, but we want something better. And the things that a lot of people use CoffeeScript for was like, oh, I want arrow functions. I just want a cleaner way to declare a Lambda. And, small little affordances like that as soon as, as soon as like TypeScript and others came on the scene and, Babel and other things that let you sort of compile to get these later functions, then CoffeeScript was abandoned pretty quickly.
Yeah, and actually, in terms of those early days, so Adam and I were developing a web app effectively in addition to for this storage appliance we were developing. Back it was like immediately post Google Maps, and it was kind of in the era of Ajax. I'm not sure if the children even Ajax, asynchronous JavaScript, and XML.
Yeah, I still call them those. I still call them Ajax calls sometimes.
Nice.
Oh, nice. That's it. This is like when we were debugging a problem and Adam's looking. Sorry.
Oh, yeah, thanks. No, feel free. Go ahead.
No. I know. Do you want me to stop?
I'm gonna go. No, go ahead. I'm gonna go take a little walk.
No. I like this is. I thought it was cute. I did. You were asking like about a trap always instruction, and I'm
That's
like,
right. I was like, we're clearly debugging some AMD 64 code, and which I mean, I guess it's anachronistic even that I call it that. And I mentioned a TA3 instruction, not a trap 3, because on Spark you had trap always, and I had Spark on the brain.
There's nothing wrong with that. So, it's Ajax calls. Like you're among friends is what I'm trying to say.
That's right.
We sound like we're just venerating you, Adam. That's all we're doing.
That's right. It is remarkable now that I've been reading a bit more about history of Sun, and the fact that we didn't get strong-armed into building that front end in like some sort of Java applet, which would have been garbage. But it's sort of remarkable that no one tried to make that happen.
Definitely, no one tried to make that happen. Yeah. We were definitely, and we were, Justin, this was the era of like, this was like Django and jQuery. And the fact that we were doing things like on the DOM, you would think we were writing it in assembly, like on the DOM directly. It's like, it's just like, I mean, they're function calls you make. I mean, it's not like, yes, on the DOM directly. But that world was very primitive, Justin, you're mentioning, and we're in a much more advanced world. And I think it's part of the reason why. I mean, I don't know that when we see the demos that you all have and the tooling that you're using, it's just like jaw-dropping. I mean, it is really, really amazing.
Yeah. I mean, the tooling in particular is outstanding.
Yeah,
so I mean,
the things that we can do are not that different, but I think it's more just sort of the confidence that we have when we make changes that we haven't broken something is really the big difference for me, at least, in the experience of developing it compared to how it used to be for me.
I would say that the engineering maturity of the whole space has really, really advanced incredibly rapidly. So there's a lot of stuff to paper over here, but I mean, even a few years ago, bundling was still a thing that was hard and cumbersome, and we had a lot of configuration, and we're trying to figure out how, essentially a software distribution problem of, hey, we have these sort of delivery payload mechanisms that we're using in a way that we weren't really intended to be used for, and we're trying to figure out how to optimize this, and just a lot of tooling churn over the years. And I think the thing that gets me excited today about the tools that we're using is like, it's so simple. It's like I can teach someone who is new to programming on a production code base, like, hey, look at this thing. Oh yeah, here's this configuration. And that wasn't the case, even a few years ago, where it's like, all right, sit down, give me the rest of your afternoon, and I'll explain what this Webpack config does. And this is no shade on Webpack. It was like doing very important things, but I think just talking about the overall maturity of the tooling, it's changed a lot.
So could you just talk a little bit more about that bundling problem? Because I feel like this is a part of the space that I never really understood when it was at its height. And I guess now that it's been obviated, it's a relief, and I never have to go understand. But I'd like to, what was the kind of the bundling challenge and problem, and how has that been solved with the tooling?
Yeah, I mean, so JavaScript, single-threaded, has an event loop. So you're parsing top to bottom, sort of executing as you go. And it's like putting asynchronous work on the event loop to sort of be popped off and ran over time. And the big thing is, in the early days when you're like building something with jQuery, you've got, one file, one JavaScript file that you're including, you're making a call and like including all of jQuery, and then you've just got this big one blob. Well, developing software and big blobs is not easy. I mean, maybe you might like working on a 20,000 line C file, but it's not a fun time for everybody, for sure.
Right. Just to be clear, I did not pay Justin to say that.
Very, very specific. That felt extremely specific.
Hey, not throwing shade at anybody.
Adam is seriously DMing you, like getting a WC-L on dtrace.c.
I mean, just the idea that we needed modularity, and so pretty quickly things like, and this is especially true as Node was coming on the scene, CommonJS came about, and we're like, okay, well, we have these modules, and we need to figure out these relatively hard problems of, as soon as you have dependencies and you have modules, then they have like there's a dependency chain here. There's a tree structure in your module graph, and you have to figure out, how to organize those, and really hard problems like, okay, when my client when they start executing, there are, maybe these 20 modules that they need to render something on the page, but we have 200 other modules with other functionality that they will need as they browse the experience, but they don't need right now. And if we delivered all of this up front, it's going to reduce the performance. And, you have all of these things to sort of think about. It's like, how do we break down the code? How do we ship only what needs to run? And, many other problems. Crespo, definitely feel free to hop in here. But that is inherently, like, it's a compiler's problem, it's non-trivial. And then just figuring out things like, what dependencies do we have? And because you have to think, you also may depend on, some CSS or some other asset, some web fonts, or, whatever. You could have a lot of dependencies. And it's just a non-trivial problem, especially when you consider that, when JavaScript was designed, it wasn't designed with like modules in mind. It's just like, hey, here's this like block of code, execute this, please.
Yeah, I think that's a great account of what happened. The only thing I would add is that what happens over time, the complexity of the tooling is a consequence of there not being consensus about what we need to do. If you think about just like the number of web apps that there are, tens of thousands, millions, and everybody was working on kind of their own custom configuration of these bundler tools because there wasn't a consensus on what a web app would need, and you really need to go through that process of trying all these things before the consensus, core functionality can really shake out, and then that enables these like really elegant tools like Vite, which is what we use to build the console in local dev and also in production. It's our config file for that's like 100 lines or something, and a lot of that is just like little utility functions that we've written. And so,
are you saying Veep, or
Vite? Oh yeah, I should spell it. The pronunciation is French. It's a VITE. Vite as in fast.
Oh yes, right. Got it.
Yeah. Well, it looks like Vite. So, but yeah, it's pronounced Vite. And it uses and it uses other tools under the hood. It's kind of a fancy wrapper for ESBuild and Rollup. But the fact that there's sort of consensus on how web apps work means that our config file can be very small because we don't actually have to make all these choices because that's just the way. Because the way that they do it by default is actually exactly what we want, and so you don't have to do all this really fiddly configuration. And that's kind of what I think about when I think about the maturity of the tooling. It's about this process of shaking out what is actually needed and what's not.
Well, getting consensus, I think it's a really interesting point about getting consensus about what the problems are, and then getting consensus that like, okay, these elements of the foundation are the kind of the right elements. I mean, I'm also going to kind of show my vintage here. Browser compatibility was such a big deal back in the day, and it feels like obviously the number of browsers has been greatly reduced, which helps. But it feels like that's just. Am I wrong that that's not as much of a problem as it was? I mean, it feels like things.
For compatibility, basically not a problem anymore.
Yeah, that's amazing. It's great. But it's another one of these things where like we need consensus on what that substrate was, so we can stop having the browser.
I think people will probably say, "Wait a second." For many people, not a problem. There definitely are people who are writing internal apps for companies that probably still have people on IE. Though if Microsoft says stop using IE, then hopefully there aren't very many companies like using IE8 to run their internal apps, except when their internal apps require IE8 because they won't run on any other browser. But
IE is definitely EOL, so don't use IE, please.
Don't use IE.
I mean, this is one of those things, though. It is worth noting that there are still browser compatibility issues. So it's like Opera is a very popular browser in certain parts of the world. So it depends on your audience. So yeah, by and large, you can hit a lot of the same groups with not doing a whole lot of work. This is good and bad, though, because mostly this is the rise of Chromium, and it's just like eating the world, which I feel conflicted about. But
Ashley had a point in the chat real quick about it's not necessarily consensus, but I would say that each tool in the space represents a consensus, and that doesn't necessarily mean that there's a global consensus, but you have this sort of convergence, and you have this plurality of consensuses.
Yeah, and I mean, you got like at least some agreement on abstractions that are productive for a significant enough subset to start getting some commonality, where you can know that like, okay, I can go build this next level of tooling and know that I don't have to solve like for 18 different ways of doing it beneath me. I mean, I do think that that's important. I mean, you want to, and there's always a tension with that. And Justin, maybe this is what you're getting at with your kind of own complicated feelings about Chromium, that like we also like we don't necessarily want monocultures, and Chromium probably is creating a bit of a monoculture there. I don't know. Could you elaborate on some of your conflicted feelings?
Yeah, I mean, you know, in one hand, Chromium is just amazing engineering. You really have to hand it to them. Like V8, the JavaScript execution engine that ships with Chromium, is just mind-bogglingly good. Like they've done so much work there. And then, you know, to the whole execution engine, it's great. And there's a proliferation of tools, you know, if you think about Electron. So Electron sort of built off of the legacy of Chromium. Electron spun out of the Atom team, the Atom editor. There's a lot of, you know, power that's come with that. But at the same time, this monoculture is a challenge. It's hard. So, for example, this is a minor gripe, but the Chrome team is sort of like pushing this browser extension manifest v3 thing that just infuriates me to no end. That, you know, they're trying to make this argument about performance and security that I can only half believe, because the project itself is, of course, backed by Google. So it's like, hey, yeah, we make money on advertisers. We're going to make technical decisions that makes it harder to build ad blockers. You know, I don't know, just stuff like that. It's like, you know, as with ever the world, it's less the technical stuff itself and more the messy reality of life. There's politics, there's money on the line, and I don't know.
Interesting. And but fortunately, it's all open source. I mean, I do feel that this is, I mean, I think ultimately this is the legacy of Firefox and Mozilla, was to get us to a world in which our browsers are broadly open source. I assume that's still true. That's still true? Is that not true?
I mean, yeah, it's broadly true, but you're talking about very, very, very complex engineering systems, right? And it takes a ton of capital. So the thing is, these things being open source benefits the corporations by, you know, giving people the opportunity to come contribute, but they are so capital intensive to develop them and to provide all the features, and, you know, I like JavaScript, the language, but it's continuing to evolve very quickly, and all the browsers have to keep up with that, and CSS is evolving, and like all these things are happening, and it's making these really complex environments. You know, we expect a lot out of the web, and we're continuing to expect more. And that does not make this an easier engineering effort. So really, if you don't have a massive amount of capital to deploy to these things, you're not going to be able to compete in any real way. And I think that really gets around this whole notion of like, oh yeah, open source is going to save us. And it's like, in this case, I don't think it's going to.
Well, it's a real tension, right, between that kind of the consensus that you need to build the tooling that you want to advance it, and then avoiding that monoculture, especially when you've got this kind of questionable, potentially perverse incentive around blocking ads, for example, and kind of blocking ad blocking. So yeah, that seems like and you mentioned V8, Justin. I mean, I actually think that this may be a bit of a hot take or a controversial opinion. I think V8, was an extremely important software project, because I think there's a certain degree that people had given up on the performance of JavaScript, and V8 showed folks that it could actually be high performing, and I think it redefined what's possible. So I actually think V8 should get an CM System Software Award. Adam, put me down.
I'm all for that. I think that's a great take. I think not only is that applicable to JavaScript, but I think people took that lesson and brought it to other languages. I mean, directly, you look at Hack and PHP, that was born from the observation from, you know, in part Keith's observation, that they could do the same thing as V8 was doing, and I think that's been carried other places. So I think it took, it helped, you know, virtual machines of that sort over a very significant hump that had sort of slowed the proliferation and let people see what they could be.
Totally. Very, very important project, and has cast a very long shadow. So, so Justin, then what is your take? Because I think the other thing that it's just, I mean, I think Adam, I can speak for both of us, has blown us away. Is David, your use of Playwright has just been amazing. That thing is crazy. Is that as good as it looks? I mean, it looks amazing.
Yeah, it's really great. I mean, I've definitely tried various end-to-end testing tools. I should say what Playwright is in answering this. So Playwright is a tool from Microsoft that lets you do browser testing. So you script the browser to essentially do what you would do when you click around the site. Every time you make a PR, you merge domain, you have these things in mind, or sort of like, what are the key flows that I want to make sure that they haven't broken. And as pretty early on in the web console project, I realized, like, okay, I definitely need to just write tests for those things instead of going and clicking around myself. And these kind of tools have a pretty long history. I mean, when I started as a web dev in 2012, and I think we had something that was, Selenium based at that point.
Right.
It was kind of similar. The basic idea is really similar, but somehow, I don't know if it's like we were talking about the browsers being standardized and not, maybe the problem of making these things reliable is not as hard anymore. Not to discount, I'm sure, whatever is the immense engineering effort to make these things good, but we just find that these tests are not that flaky. They figuring out how to select things was really tough. Like, you would have CSS classes everywhere, and you would just be selecting things by the button class, or like something that wasn't really relevant to what it was on the page. And now there's different conventions around that I think make it a little bit more reliable. But just overall, the experience of writing these tests is not that of like a massive slog. It's not very hard once you get used to it. And we have, 60 or 70 or something of these in the web console, and they are actually our primary tests. We have unit tests for things that are, more pure functions like helpers and stuff. But for the most part, these full end-to-end tests in the browser running in Firefox, Chrome, Safari, like those are our primary tests for the console, and they give us quite a bit of confidence that we are not messing things up when we make a change.
Did I ever tell y'all the story of how I got involved in open source for the first time?
No.
It's related. So I was working for this company called Adtran. They are sort of a Cisco competitor, make switches and routers, and many other things. I'm sort of minimizing their business there, but so we were using this Python testing framework, automated testing framework called Robot Framework. It was by a Finnish developer. I think he'd done it. He had developed it for his PhD, but we were using that to drive the console to, we'd have a rack of switches and routers or whatever in different configurations, and drive a BGP test or something. But we also wanted to test the web UI for this. So there was a Selenium binding for Robot Framework, and it did not work as well as I'd wanted, and the previous developer had sort of abandoned the project. So I got involved in maintaining a Selenium binding for this Python testing framework, and that was my first major contribution to open source. I helped maintain that for a year. Yeah, so it comes full circle.
Yeah, right, exactly. That was your entree into it, was around because when this has historically been one of these things that has been just rocky, is how do you actually automate testing of a user interface of something that is going to ultimately require a human being moving a mouse and so on. And because you're mentioning with Selenium, you do these kind of do it with CSS, and I just got to imagine that you end up with the test itself being brittle or potentially brittle. Was that
absolutely? Yeah, and the convention around that has changed quite a bit. So I think this is something I learned from a guy named Kent C. Dodds, who is I think he mostly teaches web dev online now. But he actually worked at PayPal when I was working at PayPal. But the trick is to use what's called the accessible name of things, which is essentially the text that's on the screen. But for things that don't have displayable text, there's also text that a screen reader would show.
Oh, interesting.
So using the ARIA role, I forgot what ARIA stands for, but essentially it's like the type of element that it is, but it's not the same thing as like the tag, the HTML tag. So you'll select a button with name, next or something, and so essentially what you do is you select by what is visible on screen. So you really just put yourself in the mindset of a user using the page instead of the sort of developer mindset of like what are the classes that I need to select for. And like if you need to select a button in a dialog, you can be like, give me the button that says next that is inside of the dialog, as opposed to the button that says next that it's on this other part of the page. And so by doing that, we can actually really exercise the accessibility of the app as well.
I was just going to say that is really,
you get it for free by testing this way, and it makes the tests much less brittle because you don't have this mystery about like what am I selecting by, what am I changing. Like when you change the text, you're going to mess up your selector, but that's not surprising because you know that you changed the text. Whereas changing CSS classes might be a much more surprising thing for a test to break.
Yeah, that's great. I mean, you've solved this other really thorny, important problem that we had Matt Campbell on whenever that was. 15 years ago on the podcast, Adam. I don't know how long we've been doing this.
That's right, anyway. Approximately that, yeah.
All right, so this is something near and dear to my heart. A little caveat here is definitely these, like using ARIA roles and using accessible names is important, and it helps part of the validation, but building an accessible web application is a whole nother thing. I mean, it's a completely different design paradigm. Like how you have to think about how someone navigates through a web UI with a keyboard and a screen reader is very, very different. So when I joined, I would done some like early work on just like making sure that experience was good. It's also a very hard thing to validate because it's different than saying, oh, do these things have accessible labels? That's fine, but it doesn't mean that you can navigate it well. So we have actually put in some real work into making sure that is a decent experience. I would say it's not perfect. We still have a ways to go, but I definitely emphasize that we've put a lot more work into this than a lot of folks do out of the gate. It has been something that, early on, I've got a Windows machine at home. I use a screen reader just to test it out, just like want to make sure, hey, can we get around doing little things like having a button that's hidden. So when you back tab or tab to the first element, it pops down this button. It's like, would you like to go to the main content? So you don't have to tab through every single menu item, in the header or whatever to get to your VPC configuration or whatever you're trying to get to, Like those kinds of things are important and they take special care. It takes rigor, it takes, a different mindset. So it's not something that you can ever just get for free, but definitely using accessible like area roles and stuff is helpful for that for sure.
Yeah, and something that I love about it is that it to me, it really just makes the app better for, sighted users as well. If
totally.
It doesn't,
right.
The structures, the clarity that you get in thinking about the structure of your application, and being able to use these patterns in the ARIA guidelines about what a list box, scrolling picker is supposed to look like, things like that. It really gives you a lot of clarity in how these things are just supposed to work for everybody. So it's been great. This is the first project I worked on where we've put this much attention into it.
That is awesome.
I've learned a ton.
Well, so and another kind of challenge that you both had to deal with is, which I imagine is like not that uncommon in the front end world, where you're trying to build something in the back end maybe it's extremely common, where like the back end doesn't yet implement that. In our case, like the back end weighs 3,000 pounds, and we hadn't even like pulled the whole thing together until we needed hardware and software to pull together. So what were some of the challenges there about having to build a console for a thing that didn't yet exist? Because I feel like you've taken a bunch of different approaches at kind of different levels to allow you to develop the console in time for the software.
Yeah, the main thing was avoiding building things the wrong way, because there's this immense weight of the past that weighs on you, even though technically you might get to a point where you've gone the wrong way and you want to scrap it, but you feel like you can't. So to me, building the wrong thing was always worse than building nothing. So I always erred like very, very strongly on the side of building less, and really being confident that it was something that we would need, and avoiding coupling and things that would make it harder to rip certain bits out when it turned out that the backend went a different way. Eventually, the backend caught up with us, and we were able to sort of build at basically as fast as we could, more and more pages in the console. But in a web app, there are certain things you need, and you want to get the architecture right. And so that was kind of what we focused on in the early time. I mean, when I started, it was March 2021, and I don't think the API was given us that much to work with until probably the summer or maybe in the fall, around when Justin started. And then we started to have quite a bit more to work with, and Justin and I ended up doing part of the solution there was also Justin and I working on the API itself to kind of help it catch up with what we needed in the console.
I was going to say, a big part of it was you just building the API and building the backend rather than waiting for it. But then there's tons of stuff you also did to separate front-end development from even having a live backend, and that's been incredibly impressive.
Yeah, so we this is actually another thing I learned from Kent C. Dodds. So this is a lot of shout outs to Kent C. Dodds on this episode. Using a mock API to avoid having to even run the real backend during development. So I think if you had told me to try this, a few years ago, I would have just thought that's just a ridiculous amount of work, and you have this enormous risk of your mocks deviating from the real thing. That's always a big problem with mocks. But the real key to making it work is that we have the Open API spec from the real API, and that tells us what our request bodies look like and our response bodies look like, and it even gives us some validation stuff like this number has to be in this range. By writing tooling that keeps our mock server in conformity with that Open API spec, that mostly solves the problem. I mean, because mostly what you are worried about when in terms of correctness is just like the shapes of the requests and responses. So by writing tooling that essentially makes that a problem of if the API changes, you just get a type error in TypeScript and you fix it. You mostly eliminate that problem of your mocks getting out of date. So we've used that really extensively. That's actually what we do most of our development with, and we just wrote kind of this fake functionality inside of that typed wrapper that implements the API in a really minimal way, and we write most of our code and test against that.
Yeah,
that
for maybe
really cool.
Maybe like a technical journey here. So this all starts, at Nexus, our control plane. So we're using Dropshot, which is a HTTP library or a sort of a REST API library. Adam, describe this better for me.
Yeah, it's a HTTP framework for like building simple web servers.
There you go.
And was one of the first things we built at Oxide. I mean, Adam, because I think you and Dave did that Dave.
Early. And to be clear, Dave did like 90% of the work. I just showed up to scoop up 50% of the glory on it. But one of the key insights that I did bring there was I really believe in interface description languages, and OpenAPI is flawed and broken, but I think it's the best thing that we have. And I think the approach that Dropshot takes is using OpenAPI as an output. So like you write all the code and then that is true. Whereas a lot of other frameworks, it's easier to get divergence between the code and the spec. And here it's as Justin is alluding to, we build the server, it outputs OpenAPI, and we know that is actually what the server is going to do.
Yeah.
I mean, that was a bit of a big bet, Adam, in terms of like the importance of the primacy of OpenAPI despite its flaws and I mean, this is a domain that you've got a ton of experience. This is something that you had spent a lot of time going into different APIs and how are these things used. And this is something that, I mean, that you came in feeling pretty certain about, and it was the right call. I mean, this is something that has paid a lot of dividends for us.
Yeah, it's been great. I'm really glad the way it worked out, and stuff like Dropshot is opinionated about how we do pagination, where you can have APIs where you find 5 different ways of doing pagination because it's built by 5 different people. So why not? But some of the stuff that like Justin and David have done, where we now get type checking across the client server boundary, is just beautiful. I just love it.
Yeah, I mean, it has been like life-changing as a client dev to have that confidence that that you're, when the API changes, it because you get type errors.
Yeah, I mean, having the spec that's true to the implementation because it's driven by the implementation has been really a key to our success. And the whole reason, I think one of the large reasons that we can maintain such a small team working on console. So we open source Oxide TS, which is the repo today, which has our code generation and stuff in it. Shout out to that.
That may be what I was subtweeting earlier today.
Yeah. So from that open API spec, we generate a lot of things. We, of course, generate like an SDK that we can use to work with the API itself, but also this sort of mock server framework that we have. This actually generates the sort of wrapper, the like implementation wrapper for those mock functions. It's like, okay, well, what is this function? What does it take? What does it expect to return? And we even have like validators to ensure that the things that we're passing in and the things that we're returning from this like mock server are in the exact shape that we expect them to be in, and they are the right format. So our mock server gives us a lot of stuff out of the box because we generate like 90% of what we need. And the rest of it is just, okay, let's do a little bit of logic to say, hey, yeah, here's this list of VPCs. If we create a new VPC, stuff it in this list. Stuff like that, where the logic that we have in the mock server is really minimal, which makes that maintaining that sort of, which is a duplicate implementation of, what our control plane is doing to some degree, like a very lighter version of it. It makes that relatively trivial, and we have correctness guarantees that we can sort of rely on in a lot of ways. It's like maybe the logic isn't correct, but for a lot of the testing and development we do in console, that's totally fine. So.
I just want to echo something you said, Justin, which was when the API changes, we get like a compile error in the front end. And I feel like that is great. And not everyone has that same philosophy, which I just don't understand. Right? Like I don't understand living in a world where you just press on in the face of incompatibility. But I think that is very common.
I mean, I can imagine there just being so many incompatibilities that you could never hope to fix them all. And then just knowing about one more is just like, a fly buzzing around your head. And you just don't want to know about it.
That's right. Yeah, maybe it's the benefit of a clean sheet of paper here where we got to build the right thing from scratch.
I think that is a big part of it. I mean, because I just think of like where mostly when the API changes, it's like, oh, actually, what I'd actually love to have is an undefined property exception, like deep in my stack. Like that's how I'd love to actually do it. If I could, I mean, I just feel that and also Adam generating the open API from the implementation, and Justin, you talking about like that's actually really important because it means that the API spec actually is correct, and I feel I got to believe that's not always the case.
I got to just to on that point. I have brought this up a lot of times in open API circles, and I am
Wait, are you about to Leventhal me right now? I have never.
No. I am viewed like a heretic. Like that idea that you would let people writing code define the spec implicitly is a type of like specification heresy. Because there's this really, really strongly held belief, and it's not that surprising that people writing a spec, right? Like people whose output is this, open API spec of the sort that you might find like a JSON schema spec, believe that the spec writers should be in charge, not the implementation authors or those responsible for implementation. But
which is wild because the spec is not human writable, really.
Well, there's that too.
It's very hard to read and write.
Yes. So I would just say I think that this is the only sane way to live, but there are people who really, really very strongly disagree with this. And in fact, feel like it is critical to have this separation, this almost balance of powers, if you will, where you have one person writing the spec and one person writing the implementation, and it's the spec that is true. And the thing that often gets lost is anything validating that the two have even a bearing passing resemblance of each other.
Totally. Talk about like Conway's law and the ramifications thereof. I mean, that's kind of crazy to me because it's like ultimately like what Dave, what you and Justin want is like, I need to know what the implementation is actually doing. Like and if the specification doesn't actually match the implementation to a degree, it's like, the implementation wins. The implementation's actually the thing that, It's the implementation.
Oh, yeah, and you get these APIs out there where, I bumped into this years ago with the Slack API a bunch, where what the open API document was out of date and wrong. And you'd file issues and they'd be like, oh yeah, we are going to do a new drop of that. And to your point about Conway's Law, it was a different team. It was the DevRel team responsible for maintaining that, which was different than the folks building the service. So it's not that surprising that it fell on the floor. Anyway, I'm done with my rant, at least for the moment.
Oh, I mean, that points at something that we do in the mock server as well, which is like what Justin was describing, is we actually generate quite a bit of the implementation as well. Because, obviously you can't generate the part where it, inserts the thing into the mock database, but you can generate the validation, right? That the same thing that the API does automatically when you, tell it what type the request body is. It's going to validate using SERDI or JSON schema.
Oh, yeah, right.
On the way in, that the thing actually matches that type. We also will do that because we have the shape and even some extra validation stuff like, number ranges. We have that. And so what we do is we generate validators with this library called Zod that lets you take an object and you essentially try to parse the object with a shape. And if it fails, it fails. So, we can 400 in the mock server. For every endpoint, it has its parser up front. That part is generated. So we get that for free. And it's really only that little bit in the middle where it's like, if I'm retrieving a list of projects, like return the list of projects. We have this little core of the implementation, but keeping that part as small as possible, I think is in line with what you're saying about, the implementation is really the truth there. So that's why we want to generate as much as we can and then define the boundary really, really carefully so that the part that we have to define manually is very easy to do. But you couldn't generate that part.
Yeah, that is really cool. And I think, and again, Justin, you made this point earlier, but we've done a remarkable amount with a very small team. This is true, I feel like, across the board at Oxide, but it is every bit as true in this domain as it is in every domain at Oxide, where we have had a very small number of people doing an enormous amount of work, in part because you've been able to rely on tooling and automation and generation of logic and code. That is really pretty extraordinary. And Dave, can you also describe what you demoed on most recently on Friday with respect to this kind of static?
Yeah,
that was crazy.
So yeah, what's really neat about this mock server, it's implemented with this thing called mock service workers. So this is a little bit confusing because it's kind of backwards. So service workers are an API in the browser that lets you essentially run a separate application in page, but it runs, I think, in a separate thread from like the main thread of the page, and you can have something that actually acts as a server and intercepts requests that your client sends. So when you use mock service workers, the mock there is because you're doing that in Node, because you're using, it was originally invented for writing like essentially unit tests on the server side where you don't need to spin up a browser. In our case, we're pretty much always just using it in the browser. So because this mock API is able to run in a service worker, we can deploy the actual front end, the JavaScript and HTML as static assets, along with the mock server implementation also as static assets, and it all just runs in your browser. So what I demoed on Friday was we're able to get preview deploys of every commit in our repo, which with functioning app, but it's deployed as a static site because the front end is static and the back end is also a static file the JavaScript that runs in your browser.
I mean, this is so wild. This is so you can test every front end commit, every feature, every bug fix, as though you were talking to this enormous, 32 CPU, 7-foot tall, 15 kW rack, and get sort of a similar or close enough user experience, which is just awesome.
Yeah, and it relies on being very judicious about the fidelity of the mock, right? Because you can have too flimsy of a mock and you're not really testing the real thing, but too complicated of a mock and you are constantly bogged down fixing it when it starts to diverge. So we give a lot of attention to getting that balance exactly right so that we're not feeling trapped by all this code that we have, and like I was saying, generating as much of it as possible so we don't even have to make that decision. That's just the way it works, and we know that it matches the real thing.
And could you describe what you did in terms of like pulling some fraction of data from the actual API, and it was like half mocked? I know I'm sounding like this. I'm recounting a dream.
Oh, that's a different one. So that's a different demo.
Right, but yeah.
Yeah. So that's actually not using the mock API, just because our the way our front end is implemented is just like a pure web app that runs in the browser. It doesn't really care what the API is. So if we proxy requests through to the real API running on the rack, you can run the app in sort of like local dev mode in your browser, where you save a file and it changes live. But the API you're talking to is like the actual API of the rack. So there are a lot of situations where the data that you're testing against, it's really hard to get realistic mock data. So, for example, metrics is really hard to come up with stuff that really covers the way that real metrics look. And other things, obviously your mocks are never going to really cover every real world case. So when we run into bugs in the rack, we can actually point our local server. We can do local dev, but just pointing at the real API, and it's just a different command to start it up. It's a one-liner difference when you start up the dev server, whether you're pointing at the mock API or a locally running copy of Nexus, which we also do, or a remote API running on the rack.
Yeah, I just thought it was amazing, and I love these kind of two together because they're kind of two different points on a spectrum where it's like, look, some stuff is fully mockable and it's great, and we can and then by the way, for the stuff that's fully mockable, why don't you have this in your Vercel preview of the PR? Which, Adam, as you said, it's just mind bending that you're actually I'm interacting with a poll. How am I what? You can actually pull up the static site and you're interacting with the PR as part of looking at it or what have you. And then for as you say, Dave, for the stuff that then there's certain stuff that's just not as amenable to mocking or what have you. And then you can actually get this hybrid deployment where you're in this developer mode but pulling actual data from the real API. I mean, I just love all the different points here in terms of all kind of pointing to how do we develop this thing quickly and robustly, which is what and I gotta say, also just the actual artifact is so crazy snappy. It is so great too.
We'll have to link a video or some kind of demo. Well, and these points are really mutually reinforcing, because the entire reason that we can draw that clean line between the front end and the back end is because of that open API spec. It really all comes down to that clean, clearly formally computer readably defined boundary being the line between the client and the server. And that doesn't mean, it's funny because one way that happens is like a Conway's law thing, where your front end devs are one group and your back end devs are another group, and you'll define the line really, really strongly just because those people don't talk to each other. But in our case, that's not really true. We work on both sides of the boundary, but so it's we gave ourselves a really clean boundary to then still work on both sides of, and that's been really, really useful.
Yeah, I think it's really important to talk about the API philosophy here. The real thing is or the product philosophy. The real thing is the API is the product, right? That's the closest thing to the rack. That is the realest sense of the word. And whether you're working in console, whether you're working in a CLI, whether you're working in any of the SDKs, it should all feel internally congruent. It should feel like the same product. And we've put a lot of work into making sure that is true in the case, right? So it's I hit the API and I can kind of see how this is structured and the language it uses and where it's organized, and you'll find that mirrored everywhere. So, something with console it's not a rich application so much as it is a sort of reformatted view of the API. And we do it to make it user-friendly and do what we can to help. But console does so little by design, both for maintainability and for the fact that any serious functionality that we handle, we want to push that down into the API. And we've had some tensions internally where we think about maybe we can do that just client side. And this is a thing that I feel really strongly about, is if we expose product functionality, by and large, where it makes sense, we have to make trade-offs sometimes, but as much as we can, we try to make that a rich API versus, we'll just do it client side.
The API is the product. Which is absolutely true. Bullseye, not something you would expect to hear from a computer company, I think, but it's absolutely true.
Not one that's not AWS, I guess, right?
Right. Exactly.
And in fact, I think whatever you say. AWS is obviously complicated. I feel like that I can stand by that bold claim. But
so
but
AWS, we're putting AWS and World War II on equal footing there, or is that
no, World War II was stressful. I guess AWS is stressful too.
Okay, well, I think they're both stressful and complicated. Okay, so
there we go. Let's split the baby, right? But the philosophy of everything is an API. It's like, yeah, that's spot on, right? You nailed it.
Well, and then just all that stems from that, like why that is so important. Because I mean, everything that you can do in the console, you can also do in the CLI. You can also do directly in the API, and then we can also. I just love all the things that have been done to like. Oh, do you want to do this thing? Do you want to do this on the CLI? Here's the CLI invocation for this. Do you want to talk to about also the overlap? I feel like documentation also comes in here as well, and in terms of like how we kind of document the I mean, say the API is the product, and kind of how the API that we end up with a locus for documentation as well.
Who's that pointed to?
Yes, silence. I don't know.
Well, one thing is we do all of our documentation inline in the code, and this is another one of like Dropshot's opinionated takes. And this is maybe a bit of a cynical one, but what I've observed, and I don't think this takes there's too deep of an insight, is like that people writing code aren't good at remembering to update the documentation, especially if it's all the way in some other file that you have to remember to open.
All the way, right? It's
no, right. I mean,
here, this other window, totally, yeah, absolutely.
Right, or maybe it's not. Yeah, exactly. It's like in Markdown or ASCII doc, but I'm writing some Rust code, so we just take the Rust docs and we make that the documentation. And it's bitten us in some ways, and sometimes you can sort of forget that you're writing user-facing documentation and start yammering about internal implementation details rather than explaining to the user what the API is. But it is sort of up there, it's right there in your face. And when you generate the docs, you see it in the JSON description and so forth. So try to put the things that we, the developers of the API, have to say about the API as close to it as possible. Yeah. So that whether you're the one changing the code, or often if you're the code reviewer who's taking a fresh look and saying, hey, the thing above says it goes left, but the code below says it goes right, it makes it a lot easier to keep those things in sync, or a lot harder for them to fall out of sync. And then that gets propagated in work that David and Justin have done, everywhere, including in our docs website.
And David's dropped the link to docs.oxide.computer, but you can allow anyone to see that documentation, which is all effectively generated from the implementation ultimately.
Yeah, and the CLI docs as well, I believe.
Yeah,
that's right.
We'd be remiss in our duties here if we also didn't give a shout out to Ben and Eugene, our designers, who have touched every part of our product, be it docs or console, industrial design, our internal RFD site, literally everything. Even
the marketing site that everyone loves.
Yeah, Wicket.
Stickers, your Oxide and Friends stickers.
Yeah, so they're amazing and they do everything, which, so props to them for sure.
Well, and props to and also just like their disposition is very much a cross-disciplinary, versatile disposition. I mean, part of what I love about just everyone is like everyone views the whole thing as part of their job. So it's like we don't, because I think that these Conway's law problems are real problems, and they the problem is they show seams to the user. Like you can see like where these I mean, I feel like with so many Google products, like, oh, I get it. Rival organizations, you do hate one of those guts. I gotcha. Yeah. Can you please? I just hope. Can we just make sure that we don't all kill one another at the same time, and so we can at least have one of these products. So I think it's really important that you got that, and I think Justin, to your point, Ben and Eugene have done a great job of stitching in across the console and the API and the docs and so on. It's been really terrific.
Yeah, we don't have enough people to build silos.
That's it.
That's right.
That's it. That is actually, boy. I mean, that is it. And like, boy, if there's a real value to that about not having, because when you do have enough people to grow silos, like the silos become a bit of a self-fulfilling prophecy, and it can be really problematic. And then it becomes really difficult to actually develop something that feels coherent. And boy, this is what you all have really pulled off. It's just been remarkable. David, there's a question in the chat about, can folks see a look at like what does this thing actually look like? This I did have.
Yeah. So I'll post a screenshot, and then when we open source the console, anybody will be able to just npm install and npm run dev and run it locally with the mock API. And we'll be able to actually link, get a link to our live demo that I was talking about as well. So you'll be able to see it pretty easily.
That is great, and very excited to get this out there, to get this open. So it's going to be people will be able to see exactly all the stuff that you have built and the kind of the tooling and how we're doing it. And I think that there's some real lessons there for other folks that are not building a computer company, but in particular the API primacy, I think, is really interesting. And Adam, and just in hindsight, that was just a really important dimension to what we were. I mean, an important thrust was that kind of API centrism, which we knew. We didn't really doubt it, but boy, seeing, I think it is surprising how many ramifications there are of it.
Yeah, I'm really pleased with how that worked out. And you're right, not wholly surprising, but I think it would have been easy at the time in those early days to say, because we had like a handcrafted YAML file of the API. Like, this is how we got early feedback on the API. And it might have been easy to say, okay, well, that's the Open API spec. Now let's go build the implementation against that. And it would have been sort of fraught in all the ways that building these APIs can be fraught. So it's worked out very nicely. And we're even generating the CLI by and large from that API spec. So it's been pretty neat.
That is really neat. And yeah, it would have been easy. That's what I mean. It's like, it would have been one of these things that it would have been easy. You can see how companies drift into this, where things are out of sync. And then all of these kind of knock-on effects of having them out of sync. It's like, well, now we actually can't actually use it to auto-generate the client-side validation. Because
and easy to see, because when you start writing it, you're like, well, we don't either we say we start from the spec and we try to conform to it, or more often you just say, we don't really need a spec for the first 24 lines of code we write. We don't have a client. The client is curl. We're not writing the TypeScript yet. So just, can we all chill out a little bit? But then as soon as you do that, it's like really hard to go back and kind of stuff the genie back into the bottle on these things, or it becomes a heroic undertaking to document it and then maintain it and so forth. So much easier, as we've alluded to, from a clean sheet of paper.
It really is. And boy, it's just amazing to see what you all built. And great job, Dave and Justin. Really terrific stuff.
Thanks.
Yeah.
Well, thank you very much, David. I know you've got a negotiated truce with a 4-year-old.
Correct.
We all know that 4-year-olds don't honor their treaties.
That's right. They really dictate the schedule of the show. We've learned over the years.
So we'll let you get back to it with a huge thanks to and our apologies for cutting into your family time.
No problem.
Adam, good luck resolving your labor dispute with the camp, or just good luck at large. I'm so sorry. We can't. I know you want this podcast to go on forever, so you don't actually have to go. But
no, I had a visitor halfway through who wanted to get on the show, but made him get a Discord account just like everybody else.
There you go. He's like, "What do you mean? I can't be known as a numeral anymore? What do you?" What's going on? Well, thank you very much. Terrific discussion and really interesting stuff. And again, great work. Really exciting to see.
Thanks for having us.
All right. Thanks, everyone. See you next time.